Hello students, welcome to today's lecture. In today's lecture, we are going to solve NCERT exercise questions on system of particles and rotational motion from 6.1 to 6.10. This is disclaimer. Learning objective. By the end of this lecture, you will able to solve questions on system of particles and rotational motion by applying concepts of center of mass, cross product of vectors, angular momentum, center of gravity, torque, and moment of inertia using proper reasoning and calculations. Alright. So, in today's lecture, we will cover exercise problems. There are total 17 questions in this exercise. We are going to cover 10 questions, that is 6.1 to 6.10. So, question is, give the location of center of mass of a sphere, second cylinder, third ring, and fourth cube, each of uniform mass density. Does the center of mass of a body necessarily lie inside the body? So in this question, you have to find out the location of center of mass of various shapes geometry. Alright. And after that, you have to find out the center of mass of a body is necessary lie inside of the body. So you have some time to solve this question. Please solve. Let's see the solution of this question. So first, we know center of mass. Center of mass is a point where the mass of a body is supposed to be concentrated. So if we talk about the center of mass of sphere, so center of mass of sphere lies at its the geometric center. Here, the red dot is the center of mass of the sphere. And if we talk about the center of mass of cube, so we can say center of mass of cube lies at the intersection of its diagonal. So we have a cube and this is the intersections of diagonal. So this one red dot shows the center of mass of the cube. All right. So now third one, ring. Third one is ring, or we can say cylinder. So center of mass of cylinder lies at the middle of its central axis. So central axis is this one, passing from the center of the cube vertically. And next is center of mass of the ring lies at the center of the ring. This one. This is, we have a ring, and this is the center of mass. Now the question is, does the center of mass of a body necessarily lie inside the body? So, center of mass does not always lie inside the body. For example, in the case of a ring, the center of mass is located at the center of the ring, but there is a no mass at that point. So at this point, red dot, there is a no mass. But similarly, we can say a hollow sphere or a cylinder would also have a center of mass that is not within the material of the object. So we can say center of mass does not lie inside the body. Yes or no? So we can say here it lie inside or outside of the body. It lie both inside and outside of the body. All right. Next question. In the HCl molecule, the separation between the nuclei of the two atoms is about 1.27 angstrom, and 1 angstrom is equal to 10 raised to the power minus 10 meter. Find the approximate location of the center of mass of the molecule, given that a chlorine atom is about 35.5 times as massive as a hydrogen atom, and nearly all the mass of an atom is concentrated in its nucleus. So here you have to find out the center of mass of the molecule. All right, think about it. You have some time. So let's see the solution of this question. Now, here we have a HCl molecule, hydrogen chloride. So this is hydrogen and this is chlorine. So that here the distance between nuclei of the two atoms, first one is hydrogen, second one is chlorine, is 1.27 angstrom. This is given. And mass of the hydrogen atom, m1 is equal to 1 unit. We consider here. Chlorine atom is 35.5 times as massive as hydrogen atom. All right. So mass of the chlorine atom is m2 is equal to 35.5 units. Yes or no? So let the center of mass of the system lie at a distance x from the hydrogen atom. So here we consider x is the center of mass of the system, this one, and the distance from the hydrogen atom. All right. Now we have HCl molecule. So we know position vector of the center of mass x of two masses m1 and m2 located at positions x1 and x2 from the origin. So here we consider the hydrogen atom located at origin. Alright, and the chlorine atom located from the origin, and the distance is x2. So the formula of the center of mass, x is equal to m1 x1 plus m2 x2 divided by m1 plus m2. Alright, now HCl molecule, here we already discussed. So the nucleus of the hydrogen atom as the origin, its position vector is x1 is equal to 0, because hydrogen, the position of the hydrogen atom at origin, so we can say x1 is equal to 0, and position vector of chlorine atom is x2. Alright, so just put the value in the formula of the center of mass. So that is x is equal to m1 into r x1. So here x1 is 0 plus m2 into x2. So x2 is 1.27 and divided by m1 plus m2. So here m1 is 1 and m2 is 35.5. Alright, now we will solve this expression. So solving the equation, x is equal to 0 plus 35.5 into 1.27 and divided by 36.5. So when we solving this, you will be get x is equal to 35.5 into 1.27 divided by 36.5 angstrom. Alright, now x is equal to 45.08 divided by 36.5 angstrom. So final answer is 1.235 angstrom. We know 1 angstrom is equal to 10 raised to the power minus 10 meter. So here we can say the center of mass of HCl molecule lies 1.235 angstrom from the hydrogen atom. Alright, a child sits stationary at one end of a long trolley, moving uniformly with a speed v on a smooth horizontal floor. If the child gets up and runs about on the trolley in any manner, what is the speed of center of mass of the child plus trolley systems? So in this question, you have to find out the center of mass of the system. And what is the system here? Trolley plus child. Please solve this question. You have some time. Let's see the solution of this question. So here we have to find out the center of mass, speed of center of mass of the system. And we know system is trolley plus child. So here we consider child and trolley constitute a single system. Alright. So child running on the trolley is a purely internal motion and no external forces is involved in the boy trolley system. So the external force on the system is equal to 0. Alright. Now solving for velocity of center of mass. So we know external force is given by F external is equal to mass into acceleration. So here the acceleration of the system is dv upon dt, rate of change of velocity or we of the system, where m is the mass, total mass. So the external force on the system is 0. So we can say m into dv upon dt is equal to 0. Alright. So the speed of center of mass of the trolley of the system is constant. Therefore, the velocity of the center of mass of the system will not change. It remains same. Show that the area of triangle contained between the vectors a vector and b vector is 1/2 of the magnitude of a cross b. Now, so here the consider two vectors. First a vector and second is v vector. So a vector is equal to ok vector and b vector is equal to ob vector, and the angle between a vector and b vector is theta. So in triangle OMN, so join the MK. So it will be triangle OMN. So we know sine theta is what? That is perpendicular upon hypotenuse. So perpendicular is sine theta is equal to perpendicular. So perpendicular is what? Mn, magnitude of Mn vector, Mn divided by this one, OM. Alright, hypotenuse is this one, this Mn is the perpendicular and hypotenuse is OM vector. Alright. So sine theta is equal to magnitude of Mn vector divided by magnitude of OM vector. So magnitude of OM vector is mod of V, this one. Alright. Now using this expression we will find the final answer. So two vectors a vector and b vector at an angle theta. Therefore mod of Mn is equal to b sine theta. B sine theta. Yes or no? So we know magnitude of the cross product of two vectors a cross b is equal to mod of a into mod of b sine theta. So just put the values. Mod of a cross b is equal to magnitude of ok vector into magnitude of Mn vector. Alright, because we know ok vector, magnitude of ok vector is equal to a vector and magnitude of Mn vector is b sine theta. So it will be mod of a cross b vector is equal to ok vector into mod of Mn vector into sine theta. So this is multiplied numerator and denominator by 2. So due to easy calculation, for the easy calculation. All right. Now two vectors a vector and v vector at angle theta. So it will be mod of a cross b is equal to 2 into area of triangle OMN. So because the product of mod of ok vector into Mn vector divided by 2 is equal to area of triangle OMK. So it will be area of triangle OMK is half A cross B, mode of A cross B. Alright. Thus the area of triangle contained between the vectors A vector and B vector is the 1/2 of the magnitude A cross B. So that A dot B cross C is equal in magnitude to the volume of the parallelopipe formed on the three vectors A vector, B vector and C vector. So please equate both equations. You have some time to solve this question. Please solve. Let's see the solution of this question. So, first of all, we consider a parallelopipe with origin O. So, sides of the parallelopipe are OA vector is equal to A vector, OB vector is equal to B vector, and OC vector is equal to C vector. Alright. So, volume of the parallelopipe is mod of A vector into mod of B vector into mod of C vector. Mod of A vector is equal to magnitude of A and so on. Alright. Now, solving for volume of parallelopipe, n cap be a unit vector along A vector perpendicular to the plane containing B vector and C vector. So here n cap is the perpendicular to plane of B vector and C vector, this one. So cross product of two vectors B vector and C vector is B cross C is equal to mod of B into mod of C sin theta n cap. Now B cross B is equal to mod of B into mod of C sin 90 degree n cap. Here theta is 90 degree. So B cross C is equal to mod of B into mod of C n cap because sin 90 is 1. Here solving for volume of parallelopipe. So now we know A dot B cross C, that is equal to A dot mod of B into mod of C n cap. And B cross C is equal to mod of B into mod of C into n cap. So using this property we can write mod of A into mod of B into mod of C is equal to cos theta. Alright. So A dot B cross C is equal to mod of A into mod of B into mod of C cos 0 degree because theta is 0 degree. Angle between A vector and unit vector is n cap. This one. A vector and n cap and unit vector both have in same direction, or we can say parallel. So theta should be 0 degree. So we can say A dot B cross C is equal to mod of A into mod of B into mod of C vector. Alright. So this is the proof. Therefore, A dot B cross C gives the volume of the parallelopipe. Find the components along the x, y, z axis of the angular momentum L of a particle whose position vector is r with components x, y, z and momentum is p vector with components px, py and pz. So that if the particle moves only in xy plane, the angular momentum has only a z component. So here you have to prove that the particle moves only in xy plane, and then angular momentum has only z component. So please solve this question. You have some time. Let's see the solution of this question. So given that the linear momentum of the particle, that is p is equal to px I cap plus py j cap plus pz k cap, and the position vector of the particle r vector is equal to x I cap plus y j cap plus z k cap. All right. So we know the formula of the angular momentum, that is L is equal to r cross p, and we know the value of r and we know the value of p. So take the cross product and you will be get the angular momentum of the particle. So just put the value L is equal to x I cap plus y j cap plus z k cap cross px I cap plus py j cap plus pz k cap. All right. So taking the cross product of r cross p, you will be get the L. Now in determinant form, cross product of the position vector and the linear momentum is written as L is equal to I cap j cap k cap, components of position vector x y z, and linear momentum px py pz. All right. So taking the cross product, first I cap, so neglect this column and cross multiply column 6 and column second and third. So it will be y into pz minus z into py minus j cap. So neglect this one and cross multiply I cap column and j cap column. So it will be x into pz into minus z into pz, z into px plus k cap. Neglect this column. So it will be x into py minus y into px. All right. So lx I cap plus ly j cap plus lz k cap. This is the linear momentum. L, angular momentum. All right. And this one is solving this. You will be get I cap y into pz minus z py minus k cap x pz minus z px plus k cap x py minus y px, because we know L is equal to Lx I cap plus Ly j cap plus Lz k cap. So here solving further. So comparing the coefficients of I cap, j cap and k cap, Lx is equal to y pz minus z py, Ly equal to x pz minus z px, and Lz is equal to x py minus y px. All right. When the particles moves in xy plane, so z component of the position vector and z component of the linear momentum, that is pz, becomes 0. So we can say z equal to 0 and pz equal to 0. Now Thus we can write Lx is equal to y into pz minus zpy, and Lx is equal to 0. So it will be for Ly, it will be x pz minus zpx. So Ly equal to 0, and it will be Lz is equal to x py minus ypx. All right. Therefore, we can when the particle is confined to move in xy plane, the direction of the angular momentum is along the z direction. Now here question arises, if the particle is confined to move in yz plane, so the direction of the angular momentum along which direction? Similarly, if the particle is confined to move in xz plane, or we can say move in zx plane, the direction of the angular momentum is along in which direction? Right. So second one in, when the particle is yz plane, so the momentum is along x direction, and when the particle is zx, then the particle is along y direction. All right. Two particles, each of mass m and speed v, travel in opposite directions along parallel lines separated by a distance d, so that the angular momentum vector of the two particle system is the same whatever be the point about which the angular momentum is taken. Please solve this question. You have some time. Let's see the solution of this question. So let a certain instant two particles be at points P point and Q point. All right. So the angular momentum of the particle, the of linear momentum P vector R is given by L is equal to R cross P. So we know P is the linear momentum, that is mass into velocity. So L become L equal to R cross mv. So solving for angular momentum, the total angular momentum of two masses with position vector r1 and r2 about point P. So about point P, the position vector is r1 and r2. So the angular momentum is r1 cross mv for particle first, for particle second r2 cross mv, where r1 is the position vector of the mass m at point P and about point P, and r2 is the position vector of mass at Q about point P. So Lp is equal to 0. Lp equal to 0 into mass into velocity plus d into mass into velocity. Why? Because r1 equal to 0 and r2 equal to d. So expression become this one. So Lp is equal to mass into velocity into d, and directed inside the paper. Alright. Now solving for angular momentum, Total angular momentum of the two masses with position vector r1 and r2 about point q. This one. So LQ is equal to r1 cross mv for particle first plus r2 into mv for particle second. So LQ equal to d into mass into velocity plus 0 into mass into velocity, because r1 is equal to d and r2 equal to 0. So LQ become mass into velocity into d, and the direction is directed inside the paper. Alright. Now solving for angular momentum. Consider a point r which is at a distance y from the point q. So it will be d minus y from point p. So pr is equal to d minus y. So total angular momentum of the two masses about point r is d minus y into mass into velocity plus y into mass into velocity, because we know the formula of the angular momentum, position vector into momentum, that is mass into velocity. So LR equal to d into mass into velocity minus y into mass into velocity plus y into mass into velocity. Solving this expression, you will be get this one. So LR is mass into velocity into d, and the direction is directed inside the paper. So now we comparing equation first, second and third. We get LP equal to LQ equal to L. Alright. This proves that the angular momentum of a system does not depend on the point about which it's taken. A non-uniform bar of weight W is suspended at rest by two strings of negligible weight as shown in the figure 6.3. The angles made by the strings with the vertical at 36.9 degree and 53.1 degree respectively. The bar is 2 meter long. Calculate the distance d of the center of gravity of the bar from its left end. Please solve this question. You have some and think about it. Let's see the solution of this question. Now, the free body diagram of the bar as shown in below. Alright. So here, a non-uniform bar magnet, this one. This is the non-uniform bar magnet, and the weight is vertically downward W. Alright. The angles made by the strings with vertical axis is 36. This one 36.9 degree, and this one 53.1 degree. Alright. Theta 1 and theta 2. Theta 2 is 53.1 degree and theta 1 is 36.9 degree. So the length of the bar magnet L is equal to 2 meter. Theta 1 is equal to 36.9 degree and theta 2 is equal to 53.1 degree. Alright. So solving this, so let T1 and T2 the tensions produced in the left and right strings respectively. So T1 produces here, here T2 produces due to the weight W. So at translational equilibrium, we know translational equilibrium, there is a no linear acceleration. So there is a no linear acceleration. So we can say T1 sin theta is equal to T2 sin theta 2. Just put the values. T1 sin 36.9 degree is equal to T2 sin 53.1. So solving this expression, T1 divided by T2 is equal to sin 53.1 degree divided by sin 36.9 degree. So solving this, sin 53.1 degree this one and sin 36.9 degrees this one. So just put the value. So you will be get the T1 divided by T2. So it will be 1.3523. All right. Now let D the distance of the center of gravity of the plank from the left. This one D distance. For rotational equilibrium, the net torque about C point should be 0. We know rotational equilibrium there is a no angular acceleration. So net torque is equal to summation I Ri into Fi equal to 0. So net torque on the system should be 0. So just put the value. So it will be D into distance is R is D into force is T1 cos theta 1 is equal to 2 minus D into T2 cos theta 2. All right. So D into T1 cos 36.9 degree is equal to 2 minus D into T2 cos 53.1. So it will be D into 0.8366 T1 is equal to 2 minus D into 0.6718 T2. Now solving this expression, you will be get the some new terms. All right. Now solving this expression 0.8366 into D into 1.3523 T2 is equal to 0.6718 into 2 T2 minus 0.6718 D T2. So solving this, you will be get 1.131 D T2 is equal to 1.344 T2 minus 0.6718 D T2. So it will become 1.131 into D plus 0.6718 into D is equal to 1.344. All right. Now 1.028 into D is equal to 1.344. So D will be 1.344 divided by 1.8028. So D will be 0.745 meter. All right. So hence the center of gravity of the bar lies 0.745 meter from its left end. A car weighs 1800 kg. The distance between its front and back axle is 1.8 meter. Its center of gravity is 1.05 meter behind the front axle. Determine the force exerted by the level ground on each front wheel and each back wheel. All right. So here you have to find out the force exerted by the level ground on each front wheel. So please solve this question. You have some time. Let's see the solution of this question. So, given mass of the car m is equal to 1800 kg, distance between front and back axle is 1.8 meter. So, center of gravity is 1.05 meter behind the front axle. So, free body diagram of the car can be drawn as follows. This one. Center of gravity is 1.05 meter from the front axle. This one. This is the front axle and this is the back axle. Alright. And the distance between front and back axle is 1.8 meter. Alright. So, let RF and RB are the forces exerted by the level ground on the front and back wheels respectively. Front RF and back RB. This is the forces exerted by the level ground. So at translational equilibrium, a net force on the car should be 0 or there is a no linear acceleration. So F net equal to 0. So RF plus RB equal to what? Is equal to mg. Yes or no? So it's solving this. RF plus RB is equal to 1800 into 9.8. Here g is 9.8 meter per second square. So it will be RF plus RB is equal to 17640 Newton. Similarly, we will solve second equation. So this is the free body diagram. For rotational equilibrium, the net torque about the center of gravity should be 0. Alright. So the net torque here, tau net is equal to R cross F, that is equal to 0. So just RF into 1.05 is equal to RB into 1.8 minus 1.05. Solving this, you will get RF into 1.05 is equal to RB into 0.75. Alright. Now, solving for RB and RF, RF divided by RB is equal to 0.75 divided by 1.05 is equal to 5 by 7. So RB divided by RF is equal to 7 by 5. So RB is equal to 1.4 times RF. Now using the value of RB in equation first, we will get RF plus RB is equal to 17640 Newton. Alright. Now solving for RB and RF, 1.4 RF plus RF is equal to 17640. RB is equal to 1.4 RF. So RF is equal to 1.17640 divided by 2.4. So 7350 Newton is the force. So RB is equal to 17640 minus 7350 Newton. So this is just mathematical calculation only. So RB is equal to 10290 Newton. Therefore, the force exerted on the front wheel is 7350 Newton and back wheel is 10290 Newton. Alright. Torques of equal magnitude are applied to a hollow cylinder and a solid sphere, both having same mass and radius. The cylinder is free to rotate about its standard axis of symmetry, and the sphere is free to rotate about an axis passing through its center. Which of the following, which of the two will acquire a greater angular speed after a given time? Please solve this question. You have some time. Let's see the solution of this question. So here, first we consider M and R be the masses of the hollow cylinder and solid sphere respectively. So the moment of inertia of the hollow cylinder about its standard axis. So as shown in the figure, this the line that is horizontal here, this is the rotation axis, and the moment of inertia is I1 equal to mr square. All right. Now the moment of inertia of solid sphere about an axis passing through its center. Look at here. We have a solid sphere and the radius is r and mass is m, and the axis that is passing from the center is the axis of rotation. So the moment I2 will be what? 2 by 5 mr square. So we know torque in terms of angular acceleration, that is alpha, and moment of inertia, that is I, is given by tau equal to I alpha, and this relation is very important. So for hollow cylinder, torque is what? That is tau 1 equal to I1 alpha 1. Similarly, for solid sphere, so torque will be tau 2 equal to I2 alpha 2. All right, where tau 1 is the torque and alpha 1 is the angular acceleration of the hollow cylinder, and alpha 2 is the angular acceleration of the solid sphere. Now, given that the equal torque is applied to both hollow cylinder and solid sphere, so the next step is we will equate both torque, that is tau 1 equal to tau 2. All right, or we know the tau 1 is I1 alpha 1, whereas tau 2 equal to I2 alpha 2. So just put the value. All right, now solving the angular acceleration, you will be get alpha 2 divided by alpha 1 is equal to I1 divided by I2. So I1 is mr square and I2 is 2 by 5 mr square. So just put the value, you will be get the alpha 2 divided by alpha 1 is equal to 5 by 2. It means alpha 2 by alpha 1 is equal to 5 by 2. So we can say alpha 2 is greater than alpha 1. All right. Now, angular speed. So consider a rotating body with initial velocity omega naught, and after times t, its angular velocity will be omega is equal to omega naught plus alpha t. And for equal omega naught and t, we have omega is directly proportional to alpha. So also we have alpha 2 is greater than alpha 1 from equation first. Yes or no? So therefore we can write omega 2 is greater than omega 1. All right. And this expression 6.36 is very important. And this is the same as we studied in linear motion. V is equal to u plus at. Hence, the angular velocity of the solid sphere will be greater than that of a hollow cylinder. Thank you for your attention.